All right, welcome to our unit on chemical reactions. Today's topic is properties of reactions. Okay, lesson 1 of 3, your objectives are as follows. Okay, to learn how we recognize a chemical reaction has took place. To learn what a chemical reaction is. Okay, and to learn how we balance chemical equations. And to learn the symbols for each physical state in a chemical reaction. Okay, for your quick write, feel free to pause this anytime you feel necessary. All right, so what sort of clues do you think indicate that a chemical reaction is happening in your car engine? And what sort of clues indicate a chemical reaction when you drop a piece of Alka-Seltzer in water? And then, what are some products produced when your body breaks down sugar in your body? What are some clues that this reaction is occurring in your body? Okay, think of temperature. Okay, go ahead and pause this while you work on your quick write. I'm going to move on. All right, so evidence for a chemical reaction. How do you know a chemical reaction has occurred? Well, there's some clues. Chemists look for visual clues such as a color or heat change, or a solid forms, or bubbles are produced, or a flame occurs. However, reactions are not always visible. Sometimes the only signal that a reaction is occurring is a change in temperature as heat is produced. So for your notes, what are some clues that a chemical reaction has occurred? Okay, question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so chemical reactions. Chemists have learned that a chemical change always involves a rearrangement of the ways in which atoms are grouped and combined with one another. For example, consider the reaction that occurs with your laboratory Bunsen burners. In this reaction, methane here, reacts with oxygen in the air. As you know, a flame is produced and heat is released. As the atoms rearrange themselves, two new chemicals are produced, carbon dioxide and water. All right, so notice here, the atoms rearrange themselves to make two new chemicals, carbon dioxide and water. So, such a change is called a chemical reaction. So, notice the atoms were rearranged. Oxygen combined with carbon and hydrogen to produce two new chemicals, water here and carbon dioxide. Chemical reactions obey the law of conservation of matter, which states atoms cannot be destroyed. They can only be rearranged. Okay, very important. So, what is, a chemical reaction? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so chemical equations. We represent chemical reactions by writing a chemical equation in which the chemicals present before the reaction are on the left side of the arrow and the chemicals formed, the new chemicals of the reaction, are on the right side of the arrow. Okay, so the arrow indicates the direction of change. All right, so the chemicals present before the reaction here, methane and oxygen, are on the left-hand side of the chemical equation, and the new chemicals formed here are on the right side of the equation. The arrow indicates the direction of change. In the reaction of methane with oxygen, we have, the chemicals present on the left-hand side of the equation are known as the reactants. All right? And the chemicals present on the right side of the equation are known as the products here. Okay, so we have the reactants that enter into the chemical equation, and then the products are the chemicals produced. Okay, so the reactants and products. So for your notes, what is a chemical equation? Okay, question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you work on this. I'm going to move on. All right, so balancing chemical reactions. It is important to realize that in a chemical reaction, atoms are neither created nor destroyed. Okay, in other words, there must be the same number of each type of atom on the product side as on the reactant side of the arrow. All right? So consider once again our reaction of methane and oxygen. All right? So the reaction is not balanced. We can see it is not balanced by taking the reactants and products apart. all right? Notice there are 2 oxygen atoms on the left side here, okay, and 3 oxygen atoms on the right side. And there are 4 hydrogen on the left side and 2 hydrogen on the right side, okay? So it's not balanced. In other words, the reaction and table show that 1 oxygen atom is created and 2 hydrogen atoms are destroyed. So the reaction cannot happen this way, all right, based on our law of conservation of matter. Remember, atoms cannot be created or destroyed in chemical reactions. They can only be rearranged. So the total number of atoms must be the same or equal on both sides of the arrow, all right? So we can fix this by putting in 1 more oxygen molecule on the left side, okay, and 1 more water molecule on the right side. So let's do that. Let's move these plus signs here. Throw in 1 more water molecule and 1 more oxygen molecule, and we're good. All right, looks good so far. The table now has equal numbers of atoms on both sides of the equation. 1 carbon, 1 carbon, 4 oxygen, 4 oxygen, 4 hydrogen, and 4 hydrogen, okay? 9 on both sides. By counting the numbers of atoms, like I just showed you, okay, you can see that the chemical equation is balanced and shows the actual numbers of molecules involved in this reaction. Okay, we group molecules together by putting coefficients in front of them. So we don't write the chemical equation like this because we group them. Okay, we put the 2 water molecules together and we put a 2 there. Same with oxygen over here. Okay, we group them and then we put a 2 there. Okay, and that's how we write a chemical equation for a chemical reaction. All right. All right, let's look at one more example here. Water decomposes to make hydrogen gas and oxygen gas, okay, or fuel for our space shuttle. So the reaction is not balanced. We can see it is not balanced by taking the reactants and products apart, okay? So notice we have 1 oxygen atom on the left-hand side and 2 oxygen atoms on the right-hand side. Therefore, the chemical equation is not balanced. In other words, the reaction in table below shows that 1 oxygen atom is created. Okay? Therefore, the reaction cannot happen this way. Remember, atoms cannot be created or destroyed in chemical reactions. They can only be rearranged. So the total number of atoms must be the same on both sides of the arrow. We can fix this by putting in 1 more water molecule on the left side, the reactant side, and 1 more hydrogen molecule on the right or product side. Well, let's do that. Okay. Throw in 1 more hydrogen molecule and 1 more water molecule. Okay, now we're looking better now. So the table now has equal numbers of atoms on both sides of the equation. Okay. Notice 2 oxygen, 4 hydrogen, and 4 hydrogen. So we're good. By counting the numbers of atoms like I just did, you can see that the chemical equation is balanced and shows the actual numbers of atoms and molecules involved in this reaction. Okay. However, once again, we don't write the chemical reaction like this or the chemical equation. We group the molecules together by putting coefficients or whole numbers in front of them. Okay, that becomes a 2. And you can probably guess what's going to happen here. That becomes a 2. And that's how we write it. 2H2O yields 2 hydrogen, okay, molecules and 1 oxygen molecule. Okay. So, subscripts and coefficients. When balancing chemical equations, it is important to note that the subscripts can never change. All right? So, for example, once again, our methane reaction down below. The subscript 4 in methane here, you cannot be changed. Neither can the subscripts 2 in oxygen or the 2 in carbon dioxide and water. Okay? Only coefficients can be placed or added. Okay, whole number coefficients can be placed in front of the compounds or molecules. Okay, so these 2's, we can only add numbers in front of them. Okay, so how do we balance chemical equations? Question on the left-hand side, answer on the right-hand side. Go ahead and pause this while you write. I'm going to move on. All right, so balancing chemical equations. I'm going to do a couple easy ones here with you. Okay, so watch. Okay, We can't change the subscripts. Remember, we can only put numbers here. So notice 2 oxygen here and 3 oxygen here. Oxygen gas forms ozone, O3. Well, what am I going to need to put in front of those to make it balanced? Well, let's see here. If I put a 3 there, that gives me 6 oxygen. Okay, what am I going to need to put here to give me 6 oxygen? You guessed it, a 2. Okay, so 2 times 3, 6 oxygen. 3 times 2, 6 oxygen. We're good. Next one, magnesium metal plus oxygen gas makes magnesium oxide. Well, if I put a 2 there, that gives me 2 magnesium. So I have 2 oxygen and 2 magnesium on this side. What am I going to need to put over here to give me 2 magnesium and 2 oxygen? Okay, that's right, a 2. And now we're good. 2 magnesium, 2 oxygen, 2 magnesium, and 2 oxygen. Okay, now it's your turn. All right, so go ahead and practice. Try these on your notes. Go ahead and pause this while you work on these and hit play when you're ready to see the answers. Okay, so let's try a couple of these. Sodium plus chlorine gas, there's 2 chlorines here, makes sodium chloride. Well, if I put a 2 there, that gives me 2 sodium, and I have 2 chlorine. What am I going to put over here to give me 2 sodium and 2 chlorine? That's right, a 2. There we go. Okay, iron metal reacts with oxygen gas to make rust. Okay, a reaction you're all familiar with. But notice here, I have 2 iron here and 3 oxygen here. 1 iron and 2 oxygen. So, well, let's just put a 3 there. Now that gives me 6 oxygen. And if I put a 2 here, okay, I have 6 oxygen. But now I have 4 iron. So, if I put a 4 there, well, we're good. 4 iron, 6 oxygen, 4 iron, 2 times 2, and 2 times 3, 6 oxygen. Okay? And you may have noticed that the reaction here with aluminum is exactly like the reaction above it with iron. So, okay, same thing. If I put a 3 there, that gives me 6 oxygen. Okay, I need 6 oxygen on this side, so if I put a 2 here, okay, that gives me 2 times 3, 6 oxygen. But now I have 4 aluminum, so I put a 4 there, okay, and we're good. It's balanced. All right, and the last one here, sodium plus fluorine gas. Remember, we always write our diatomic molecules here with 2, oxygen, chlorine, fluorine. They always, okay, form, in nature, they're always in a diatomic state. Okay, so sodium plus fluorine gas. Well, if I put a 2 there, I now have 2 sodium and 2 fluorine. That's good because now that I have 2 fluorine, I have 2 fluorine on this side, but now I have 2 sodium. So if I put a 2 there, okay, I now have 2 sodium. So we're good, we're balanced. Hopefully you did well on those. Feel free to go back and practice again if you need more practice, okay? So physical states, the last thing we're going to talk about here today is physical states. In a reaction, we often use symbols to represent the physical state of the reactants and products. Let's look at this reaction below when sodium metal reacts with water. Okay, sodium is a solid metal, all right? Then we have water in the liquid form, hydrogen is gas, and sodium hydroxide is what we call aqueous. Okay, so the symbol S here tells us that sodium is in the solid state. So sodium is a solid when this reaction took place. Okay, the symbol L tells us the water is in the liquid state when the reaction took place here. Okay, and what formed here was hydrogen gas. Okay, so the symbol G tells us that hydrogen is in the gaseous state. And the last one here, perhaps the most important, the symbol AQ tells us that sodium hydroxide is aqueous or dissolved in water. Okay, so aqueous just means it's like sugar or salt dissolved in water. Okay, so sodium hydroxide is dissolved in water. Okay, so what do the symbols represent in a chemical equation? Question on the left-hand side. Okay, answer down below on the right-hand side of your notes. Go ahead and pause this while you write. I'm going to move on. Okay, so summarize here. Explain the law of conservation of mass in your own words, okay, and apply it to chemical reactions. What is the difference between the reactants and products in a chemical reaction? Describe the process of balancing chemical reactions, and be sure to explain how you count atoms on both sides of the equation. What can you not change when balancing chemical reactions? Okay, and then, is the reaction below balanced? Explain why or why not. Okay, go ahead and pause this while you do your summary, and we'll see you next time.